Hello everyone. In this video, we will see how to work with dataset given in CSV file to train our TensorFlow 2.0 model in Google Colab. First of all, you have to expand this palette where you will find files section. Inside this section, you have to drag and drop your CSV file. CSV file is comma separated values file where we will have multiple values separated by comma. So in this case we have 9 different values for each sample. Out of these, first 8 values are called as input feature, while the last column is representing the actual output associated with that sample. Now we have to drag and drop this file to a palette. So just drag and drop that. Here we can see we have 77.07 GB data available for the disk. So we have successfully added .csv file to a file section. Now import file libraries. After that we want to read this CSV file with the help of Pandas as a data frame. So for that we have to use pd dot read CSV file, and after that we have to specify file path. So click on this 3 dots and select the copy path, then specify that path in double quote as a parameter to read CSV file function. You have to specify whether this particular CSV takes header or not. So in our case we don't have any header line in the data set, so we are specifying header is equal to none. We can take this data frame for further activities. So get the description for the data frame. We have to use data.describe method. This method provides us count, mean, standard deviation, minimum deviation and maximum value available inside it. So we have samples in our data set. So let's print out few top samples from the data set. So we have printed out 5 different samples with the values. Okay, now we want to change the data type of each column to float 32. So execute this cell data dot as type into bracket float 32 will change data type of each column. As we can see, all the values are converted to the float 32. Now we have data frame, but for further processing we need to convert that data frame to a numpy array. To numpy function will convert our data in a numpy array. Then let's print the shape of the data. So now this data is a numpy array. Now we have complete data set. So we want a training data set separate and testing data set separate. We can do easily by using colon to specify the shape. So first 700 rows will be used for the training purpose, and last 68 rows will be taken for the testing. So we can print the shape of training and testing data set, that is 700,9 and 68,9 respectively for training and testing. Now we have training data set, we have testing data set. Now from the training data set we have to separate input features and the true label associated with it. Same is true for testing. That can be again easily done with the help of colon. First part before comma indicates the number of rows that we want to take. For training purpose we are interested in all the rows and all the columns except last one. That can be done by specifying values after comma like 0 colon minus 1 means minus 1 indicates skip the last one. Same is true for the training. First colon indicates we are interested in all the rows, and minus 1 indicates only consider the last column where we have true labels. Same procedure we can apply for testing features and testing labels also. Let's print the training features shape and training labels. So we are getting 700 comma 8 and 700 as expectation. So there are 8 different features which will be treated as an input to our neural network. Now import classes and layers and models that we want to use for our model definition. Then we have created a sequential model with input layer shape is equal to 8 comma empty. So this shape we have retrieved from the first samples shape. First sample shape is 8 comma empty. So we are using the same over here. After that we have added dense layer with 16 neurons and activation as ReLU. After that we have added dropout layer. Again after that we have added dense layer followed by dropout layer, and last layer is output layer where we are including only one neuron to classify the things. Only one neuron is sufficient since this is a binary class classification problem and its activation is sigmoid. Now let's configure the training for our model with the help of model.compile. We have used stochastic gradient descent algorithm with loss as binary cross entropy and matrix as accuracy. In model.fit we have to pass training features along with the true labels, that is training label. We have used 100 epochs over here. Validation data is testing features and testing labels. Now execute this model. Okay, we have got accuracy up to 65% with loss 0.64. We have got validation accuracy as 60% with loss 0.67. Okay, so this is how we can work with .csv file. Okay, but problem with this particular method is this file is available for 12-hour session in Google Colab. After that, if we want to use this file, we have to reload this file again. Imagine if we are working very huge file, then we have to upload that file again and again. So instead of that, we will attach Google Drive to this Google Colab program and we will use that file forever. So that tutorial we will see in the next video. Thank you for watching the video.